All right, so tonight's presentation is a conversation about REST. And the reason I titled it this way is we are going to talk about REST APIs. We're going to look at some code examples. But it's not just your normal, hey, this is how you build a REST API and things to watch out for. As I began implementing a REST API for a project at my employer, I ran into some very interesting corners of the REST world. And so this presentation came out of that experience and that research. So again, it's more of a conversational type of tone. You're going to find that as we go along, we're going to kind of shift. The slides they're sectioned together, but the focus of the conversation is going to shift. And so it's kind of three different kind of mini presentations all rolled into one, and it'll all flow together, and you're all going to love it, trust me. But it's not your typical, hey, we're going to watch 22 slides, and when you get done, I can follow the same steps, and I'm done. This is more about a conversation. If I don't know anything about REST, or I'm going to start with REST, or maybe I ran into some problems with REST, we try to cover everything. So we're going to go through all of that. We have a demo of a REST service actually working, so we can post some data and get some data out and see how it actually works and interact with it. And then at the very end, I have my code base. I wrote a REST API inside of Zen Framework. And we'll get into the whole reason why I did that and all that kind of stuff. So we'll have actual literal live code as well as a working example. Okay, so what is an API? We'll start off right in the very beginning, get everybody up to the same level, the same speed, and then we'll go from there and start talking about REST. So, no great presentation can start without a definition from Wikipedia. So, an application programming interface is a particular set of rules and specifications that a software program can follow to access and make use of the services and resources provided by another software program that implements the API. I promise I'm not going to read all these slides to you. Wikipedia continues. Serves an interface between different software programs, facilitates their interaction, etc., etc., etc. All right, what does that mean to us? It's a set of rules and specifications to facilitate the interaction between different software programs. How many of you have ever used an API? You should all have your hands raised, because even if you didn't realize you were, you were. For example, if you've ever done a make directory command in a Unix server, or you ran a format on a disk, you used an API. Instead of having to know how to go in and reset every single bit on the disk back to a writable state for every single bit on a 2 terabyte drive, instead all you have to do is run the format command, preferably not your root drive after it. Hit enter, walk away, come back, and you're done. So an API, the real world example right there, it packages it up the interface and the interaction to the underlying programming system for you in a very nice, easy way. All right, so there are several types of APIs in the web world. We're talking just web. Obviously, if you're doing like Windows application development, there's a whole myriad of APIs. But in the web world, we've got XMLRPC, SOAP, JSONRPC, and REST. So the dates after each one of these is roughly the date that they were introduced and people started using them. Doesn't mean they weren't around before, doesn't mean when they became popular, but just kind of give you a rough timeline here. So XMLRPC came out in 1998. SOAP came out about the same time. In 2003, the recommendation to the W3C standards group was submitted for SOAP. SOAP is still not an accepted standard, and we'll talk about that a little bit, but just so you know. Then JSONRPC came out in 2005, and you'll notice that REST has actually been around pretty much since the beginning, and there's a reason for that as well, and we'll get to that. So we're going to talk a little bit about each one, and the reason for that is because REST is different than the other three on this list. And you have to understand that difference to understand what makes REST REST, and why you want to embrace REST, and it'll make the rest of the presentation and the code make sense. So, XMLRPC.com has a definition of what the XMLRPC API is. It's a remote procedural call using HTTP as the transport and XML as the encoding. It's designed to be as simple as possible while allowing complex data structures to be transmitted, processed, and returned. So XML over HTTP. It also says, according to the creators, that they also wanted a clean, extensible format that was very simple. It should be possible for an HTML coder to be able to look at a file containing an XMLRPC call, understand what it's doing, be able to modify it, and have it work on the first or second try. and then the unicorns run around the corner. We also want it to be an easy protocol that could quickly be adapted to run in other environments or on other operating systems. How many of you have ever worked with XML in any capacity? So this is the simple part that it's supposed to be. The reality of XML is it is never this simple. So XMLRPC was one of those implementations where the theory was great, but the actual practical real-world application, it's a headache, which is why some of those other API formats came about, and we'll talk about those. So in XMLRPC, remember, you would send XML data over HTTP. So you would create your XML document. Where's my pointer? You create your XML document. We're going to say it's a method call. What's the name of the method I'm going to call when I get to my code on the endpoint on the server? I'm going to send a bunch of parameters. Here's my first parameter. It has a value. It's an integer of 40. So you got to do all this work, and you send it across the wire. And at the other end, your code that's sitting on the server is going to take this code. It's going to look for the method name, saying, oh, I've got a function called that, or a method. Back when this was implemented, there wasn't a whole lot, at least in the PHP world, there wasn't a whole lot of methods actually being called. These were really functions. Because object support obviously wasn't all that great in 1998 PHP. And so anyway, that's what you send across the wire. And you can expect to see something like this as a sample response. Again, you'd have a well-formed XML document. It would tell you that it's a method response. It has some parameters. It has a value. The string is South Dakota. So in this particular case, we said, hey, get the state name where the ID is equal to 40, and it hands you back South Dakota. And this is the type of payload you would expect to see going back and forth across the wire. In an extremely simple example, because it's never this simple. It ends up being like 80 pages of XML, 95% of it is namespaces, and it just falls apart really fast. It wasn't XMLRPC's fault, it's XML's fault. Okay, so how can we handle all of that type of data and still have something simple? Hey, I know, let's use SOAP. Because it's a lightweight protocol for exchanging information in a decentralized, distributed environment. XML-based protocol consists of 3 parts. An envelope that defines the framework for describing what's in the message and how to process it. A set of encoding rules for expressing instances of the application-defined data types. And a convention for representing remote procedural calls and responses. Now, SOAP has some flexibility over XML-RPC. Because it goes over HTTP, and it has this envelope, you can actually send SOAP messages over SMTP or other network protocols. Because of that envelope telling it how it's encoded, it doesn't really care the protocol that it's using to get there. As long as the other end can receive it in its entirety, then it can tear it back apart. So SOAP did offer some flexibility. Who's ever used SOAP? Who would consider it lightweight? Fun? Easy? Yeah, exactly. So SOAP was worse than XMLRPC. Nothing about SOAP ever works out of the box, ever. Unless you happen to be writing a script that's talking to a script in the same directory and you really don't want to do anything. Other than that, SOAP, it'll drive you to drink. It is not fun in the slightest. So sample request SOAP would look something like this. Remember, we still have a XML is what we're sending. But now we've got this envelope that's wrapping everything. And we've got namespaces. This is usually when I stop getting interested in SOAP, because getting these to work, between like a .NET backend and a PHP consumer client, or vice versa, or Java, or anything like that, it immediately falls apart. Then we've got a header where we can send some information, and we're not in this example. Then I've got my body. Then I'm going to call this method, and it's got its own namespace. It talks about how you can define things, and then I'm going to send it stock name, et cetera, et cetera, et cetera. You could also support a few other things with SOAP that you can't do in XMLRPC, such as you can do authentication. And I don't just mean, oh, well, I can ask for username and password and send that with HTTP, auth headers, with XMLRPC. I mean true encrypted, signed certificates, all kinds of stuff. You can throw the I always forget the name of it, SSI, I think it is, security scheme on top of SOAP. I have never gotten that working. Even when I've had the vendors out-of-the-box tools that you install and you follow the SDK. So, JSONRPC. This one is a remote procedural call protocol encoded in JSON. Very simple, very similar to XMLRPC, defines only a handful of data types and commands. This one is by far the absolute easiest way to do a remote procedural call style API. Ridiculously simple. Sample request. I'm going to build a JSON object. I'm going to pass in my version, my method, my ID, pass in some parameters, my response, I'm going to get back my version, my result, my error, and an ID. Now, you might be asking, why do I have some of these extra parameters that are here? According to the JSONRPC spec, if you wanted to be completely within compliance, which is very important in like an enterprise environment where you don't know which kind of third-party systems are going to be talking to your API, and they might have followed the rules and that kind of thing, you need to make sure that in the request, you are setting a method, an ID, and parameters. They have to be there to be following the spec and the standard. Likewise, in the response, a result, an error, and an ID must always be returned. Now, just as Daniel and a few of us were talking before the meeting, he's working on some API thing. You know what? If you got one little script, you just need one little thing, and it's kind of a one-off. If you put an open brace, your data with a name-value pair and a closing brace, and your script works and gets the job done, and it's JSON, and it's RPC, congratulations. You have a JSONRPC API. And you can go home early, and the stuff's probably not going to break. So again, according to the spec, you're going to have these extra parameters. But in your own practical use, who wants extra work? I certainly do not. All right, so we have talked about XMLRPC, SOAP, and JSONRPC. Anybody have any questions about those before we switch gears into REST? And if I'm going too fast, let me know. I might be talking fast for too time. All right. So, what do these three types of APIs have in common? They are all service-oriented. They are all pushing data to an endpoint on your server. Remember when we were talking about method names? They're all expecting a chunk of code to be executed. And you're going to tell it what chunk of code you're going to execute because you tell it the name of the method. And that method might literally be the name of the function in your code, or maybe it maps to something else. It depends on how you have your architecture designed. But at the end of the day, you're saying, here's data, and I want you to pass it in and run this function against that data, and then I'm expecting a response back. It's service-oriented. REST, on the other hand, is resource-oriented, which is a completely different approach to how you do APIs. It's a completely different approach to how you organize your data. And if you have the opportunity, when you're designing a project from the very, very beginning, and you know you need an API, that is the absolute best time to be thinking about REST. Because you can help yourself a lot by organizing your data around the concept of resources, or depending on your project, entities, business objects, those types of things, that concept. REST will come together very nicely for you. If you have to try to put a REST API on top of a I didn't consider REST when I was building this type of application, it can be done, but you're going to need some translation code that kind of help map the concept of resources exposed to your API and a series of underlying procedural code or functions or those types of things. It absolutely can be done, but from the very beginning, ground up, by far the easiest. So service-oriented architectures are designed to call methods, whereas REST is going to transport resources. And we're going to get into what that means. All right, REST stands for Representational State Transfer. That's where it gets its name from. Dr. Roy Fielding is the one that came up with REST. You can go out on the internet and search his name. You can read his dissertations. He's very involved still in the guidance of REST. He co-authored the HTTP 1.0 and 1.1 specification. REST was designed alongside HTTP 1.1. So the guy that came up with REST knows what he's doing. We use his stuff every single day. And you'll find as we start going through these conversations, REST was intended for how the internet was supposed to work. And the browser vendors decided to go a completely different way, and we ended up with the internet that we have today. And you can thank mostly Microsoft for that, but there's a few other vendors that are guilty as well. But they're the predominant offender of that change in direction. And we'll talk about some specific examples as we go along. All right. Some of the guiding principles of REST. Identification of resources. So when you have a URI, or URL, but URI is the technical correct term because it's more encompassing. When you have a URI, you should be able to look at it and immediately be able to tell which resource you are talking about. That's the first guiding principle of REST. Then you should be able to manipulate those resources through representations. I want to be able to create a new one. I want to be able to edit one. I want to be able to view that. They should have self-descriptive messages. And the concept of hypermedia as the engine of application state, or HADOS, or however else you want to pronounce it, like with every other acronym on the internet. And we're going to walk through each one of these. All right, the first one, identification of resources. Individual resources are identified in requests, for example, using URIs in web-based REST systems. Here's my API, api.myapi.com, article/12. By looking at this and knowing that it's a REST URI, I immediately know that I am dealing with an article resource whose identifier is 12. That is a resource, that is a concept. I can now edit that resource, I can delete that resource, I can view it, I can copy it, I can move it. Anything that the API will expose to me as functionality, I can do. But I don't do it by adding anything else back here. I don't put a question mark, action equals edit. I don't, none of that stuff. It's not the web the way you're used to seeing it, and it's not any of those RPC calls. This is all it is, and then you manipulate it via messages, and we'll talk about those in just a moment. This tells me, again, I'm at my API. This is and I know that I'm, consuming a REST API. This is a collection of individual article resources. So if I was to send a GET request to this second URI, I would expect to get back a list of article resources that I could then go and access individually in a format such as this. So we have resources and groups of resources, but again, it's always about resources. And this is just a little bit more, I wouldn't say advanced, but it lets you know that you can have levels of resources. So this tells me that I'm looking at a customer resource that I can identify with the ID of 4, and I'm looking at their number, order 18. Because the way I've decided to, so what do I want to do is, expose my resources via my API is that order resources are going to be children of customer resources. Now, it does not mean that that's how it is inside my system. Maybe it's the other way around. Most likely, they sit side by side. They have a relationship to each other, but they don't have an ownership to each other. Because I could get to an order and then find all customers that were on that order. It just depends on how your system works. But because of this organization, it tells me that I can get to my order resources underneath my customer. And I might have another endpoint that lets me see my orders also. Again, it's just about resources and how you want to expose them. All right, so once we have some resources that we can get to like this, we know where they exist. How can we manipulate them? How can we interact with them? Get. And this will return a representation of the resource requested. All right, so how many of you are familiar with a GET request? Every time you go to a web page, if you type it in, a URL, and hit enter in your browser is issuing a GET request. And it's doing exactly that. It's going to the server, and it's getting that information back. Now, it does not mean that that's a REST API. That just means that GET is used as an HTTP methodology to retrieve information from the server. There's a whole bunch more of these that we can do, and REST utilizes all of these for you to interact with your resources. Put will replace a representation with a new representation, or create it if it does not exist. Okay, how many of you even knew put was a possible way to interact with data on the server? Okay, how many of you use it in the browser? Yeah. So we're back to that comment a few moments ago about how REST was great and HTTP was great, and Dr. Fielding had this grand vision for how the web should be used. And then the browser said, well, you know what, we're going to use GET everywhere. All right, fine, on a form, we'll let you post. We're going to do everything through the URL. Question mark, name value pairs. You're going to get, you're going to delete, you're going to put, you're going to do all these things through optional arguments on the URI. We're not going to support the actual HTTP methods. Even though the servers know how to handle them, they're in the HTTP spec since the beginning of the internet, and we've got this wonderful architecture of REST that puts it all together for us, we're going to do something completely different because we're special. And for the last 10 plus years, we've had to deal with the fallout of that decision by the browsers, which is why conceptually REST, when you talk to a lot of people, it seems so foreign to them because it's not how you browse the internet on a day-to-day basis. But if you stop and look at how the spec was designed and how computers are designed to talk to each other, REST is pretty darn near perfect. It's architected this way. So, a couple more. We can post. This will create a new resource. We can also delete the resource. So these are the main ones that we're going to look at tonight. There's others we'll talk about, but I have demos of these. Get, post, put, and delete. All right, so that's how we can manipulate the resource. If I have customer 12, I can I can delete customer 12, I can get customer 12, I can put data to customer 12, which will update it, or I could do a post to customer, and it'll create a new customer for me, because again, it's all about resources. I'm not talking about a specific resource, but I'm talking about the resource as a concept. All right, self-descriptive messages. This is the third guiding principle behind REST. Each message includes enough information to describe how to process the message. All right, so for example, we'll use a content type header. I have a resource on my server that is a circle. Now, you can argue that that's not necessarily, what kind of resource is that? But bear with me, it makes an excellent example. So I have the resource of a server, or excuse me, I have a circle on my server. I'm going to issue a GET. How is that circle going to be represented to me? Well, using the content type header, if I tell it I want an image JPEG format, this is what I might get. An actual literal binary object that is a JPEG image. Because that is a circle in the content type of image JPEG. But that's not the only way I can represent a circle. There's also mathematical formulas for circles. So if I was instead to ask for that same resource at the same URI in a different content type header, if I ask for an XML, could I not also get back a radius and a unit of measurement for that radius? Are these not the same resource? Different representations. Because each message should include enough information to describe how to process it. Does that make sense to everybody? And it's okay if it doesn't. Not trying to speak down, but REST is different than every other API out there. Okay. Another example of self-descriptive messages are response codes. My client application can respond, or my consuming application rather, can respond to these response codes. There's about 60 of these. I wrote down some of the more fun ones, some of the ones you're going to see the most often. If I issue a GET and it was successful, I would expect to see a 200 OK, and then there's my data. I know it's OK to continue processing. When do you think you would see a 201 created? Yeah, when you post the data to a resource, absolutely. And that's how you know it was created successfully. See other, we're going to see some examples. Unauthorized, obviously that makes sense. Not yet implemented. Maybe one of the resources doesn't support a GET because you've only got around to writing the post for whatever reason. You don't just leave your response just hanging out there. You reply with a 501 not implemented. So your consuming, not your, but the consuming application can respond appropriately to it. Because they're supposed to be self-descriptive messages. If I ask for a image type, or an image of JPEG, and I don't support JPEGs, again, I don't just die. I don't say not found. Those aren't valid responses for the situation at hand. sending back a 415 unsupported media type is. Now, just imagine if your browsers actually did this. Like, in theory, they're supposed to, according to the HTTP spec. It would be fantastic. You wouldn't have broken links. Well, the links would still be broken, but you'd be able to respond to them more correctly. It would know if links are broken. It would know whether or not it couldn't display a certain media type, or whether there's an alternative media type. Maybe when you're looking at an image, you could say, oh, not only is there an image, but I can get this as flash and as text, and instead of right now, what do you have to do? Oh, see other, and you have to put a bunch of hyperlinks to point people to it. Because the client, i.e. the browsers, aren't smart. They're not RESTful. They don't follow the specification. If they did, and they don't, if they did, our life as a programmer would be much, much easier. Perhaps not as a programmer, but a front-end client consumption when you're developing the actual website. From a back-end engineer standpoint, I don't care if the designer has to put 2 more links on the page. But when I'm building that web page, I got to find room for them and all kinds of crap. It's really annoying. Okay, 4th guiding principle. KDOS, or hyperstate as the engine of application state. Hypertext, right? Excuse me. All right. Just like with HTTP, there is no maintenance of application state. If you are on a website, you issue a GET request, you get the data back, you then issue another GET request to that server. You are as unique as the first request, as the second request, as the 10 million other requests it is serving. There is no concept of application state between page requests or resource requests. Same thing with REST. Why? Because they're both based on the HTTP 1.0 and 1.1 standard, which says there is no maintenance of application state. So they're not trying to be different. They are the spec. Cookies are bad. Very, very, very bad when you're developing a REST application. Now on the web, we use cookies to maintain application state, don't we? We issue a session on the back end, we write some sort of identifier to associate the back end session with the front end client request, and on every request we send that cookie so we can pair it back up. What kind of problems does that cause in general with that type of application or that type of architecture? It's like one of the big things you can't do with that type of architecture, or you can't do very easily. So, pick it.
The load balancing?
Exactly. Load balancing and scaling. You immediately run into problems with that type of approach. So again, it is a workaround that the web development community has just had to go with, partly because of the browsers, partly because of technology at the time, et cetera, et cetera, et cetera. It is what it is. We can't change it. But the world we live in can be different. And related URIs should be included in representations of the resources. So, what this means is, let me go back to the cookies for a second with the application of state. In a RESTful application, you need to send authenticating credentials on every request. That is the spec. Because there is no application state being maintained, you re-authenticate every time. You send an API key on every request. Or you send some sort of credentials depending on what your environment is. If you're doing like OAuth, it's okay to send them and re-authenticate every time. Now, does this mean that you can't keep some sort of concept on the back end of a user object and application state and send it back? Yeah, you certainly can implement something, but you're not going to want to. It's just not worth the headache. Embrace the idea that you're supposed to authenticate on every request. It'll make your life a lot happier. You can instantly scale. And you don't have to worry about any proxies along the way caching things. You don't have to worry about client applications having to change because you changed the way you were handling application state or your business logic. Think separation of concerns, and that's where we're heading with that. We're going to show examples of all of this. Related URI should be included in the representation of the resources. It goes back to what I demonstrated and what I also talked about a little bit, which was if I'm sending you back a resource and it's a circle, and I'm telling you here it comes as an image, I'm also going to have see others. See it as XML, see it as text, see it as, I don't even know whatever else way you could represent a circle. But all the other ways that I can represent this resource to you, I'm going to include in my response. So you, the client, the consuming application, can decide what to do and know what options are available to you. REST is fantastic between computer to computer because if you can imagine, you have your REST API, you have one page. I go to myapi.com. What does it do? With a GET, it's going to list out all of the top level resources. I have customers, I have orders, I have whatever. Those are collections. When I go there, I'm going to get a list of individual ones that I can go to, depending on your levels of authentication and all that kind of stuff. I can basically spider that. And that's one of the ideas in computer-to-computer communication with REST, is that a computer should be able to follow all of these resources and respond to them. You don't need a human to look at the data and say, well, it says to click here to see this, but when I mouse over, it's actually got a PDF extension, but it says, and you got to apply some logic and then go, well, I guess I'm just going to click it and see what happens. Then you get something you weren't expecting, and there isn't a need for human intervention. Program to program, application programming interface. Now, it does not mean you're not going to write consuming client applications such as a website or a desktop app that's consuming a REST API. And there's some visual, tools for the user. Hey, when I see several of these, I'm going to create a, see more types link, and you're going to react to this data. But you got to think computer to computer. All right, so that is enough of me talking for a little bit through all these types of slides. We're actually going to look at actual examples now of consuming a REST API. So, a lot of examples.